Welcome to my talk about workload memory protection. My name is Sören Schmidt and I'm part of the SAP Technical Alliance team. And for the next 30 minutes, I will talk a bit how you can keep your SAP applications in memory with the help of workload memory protection. So that's our biggest mission. We want to keep SAP applications stay in physical memory, and we want to avoid swapping. And if we look in the past, we have seen two typical cases when we saw swapping. The first one is that besides an SAP application, there was a third party, so another application installed, which started to consume a lot of memory and which caused the kernel to swap out the SAP application. So in the past, there was only one solution for that. The admin has to take care of that and either reconfigure the software, if it's possible at all, or just simply do not install such software on an SAP system. The second one was a little bit more common, was that swapping happened to your growing page cache. So the result was the same. The SAP application gets swapped out. And we saw this very often together with backups running at night, which did not use direct I/O. So those backups caused page cache growth, and the next morning there was the big trouble because when everybody came back in the office to log on, then the great swapping started. So to have an answer for that particular problem, the page cache limit was introduced in SLES for sub-applications, 11 SP1. But with the page cache limit, there are some problems with it because this feature never was accepted in the official Linux kernel. It was only all the time what was a SUSE thing, and we always had to patch the official kernel with that feature. And doing that over time is tricky and complicated because the kernel obviously is changing. There's new developments, especially in the memory management, and it became much more difficult to patch the kernel there. And even lately, the implementation started to cause issues with large amount of memory because the memory built in machines back in the time where with SLES 11 was significantly smaller than nowadays. So in the end, the page cache limit has been removed in SLES for sub-applications 15. So you need an answer, a replacement, and that's where workload memory protection comes into play. So the idea here is exactly the same. Try to prevent paging out of sub-applications. But little difference here against any form of memory pressure. That not only the page cache grows, so the second case we saw, but also the first one, so that an application tries to allocate memory, workload memory protection wants to protect you against that threat too. So good thing on WMP is it is not a special dedicated SUSE-only kernel feature anymore. It's based on the cgroup memory controller, and cgroups are part of the official kernel. So we see there's a problem there. But like, even if it is a kernel feature, it is like the page cache limit, which was a kernel feature too. It's only supported for SLES 15 for sub-applications, SP1 and SP2. 2 is already out. SP1 is in QA, so you can expect the release soon. But again, it is a benefit of SLES for sub-applications. So I mentioned cgroups several times already. What is it? Brief introduction, a very brief introduction for those of you who don't familiar with that. Cgroups, short for control groups, is a Linux kernel feature for a long time. And the idea behind is to organize processes into a hierarchy to limit, account, or isolate resources like CPU, memory, I/O. And we have two different versions currently. That's first one is version 1, which is still very common. and it's the default in SLES. But meanwhile, there is a complete redesign. It's cgroup version 2, which is available in SLES12, SP5, and SLES15. And we see version 1 is, let's say, deprecated. So we see a movement from version 1 to version 2, and already several community distributions have done that switch. So cgroup version 2 is definitely the future. And cgroups 2 have a feature what we need here. So it's feature version 1 is lacking the feature, so we have to switch to 2 and the version 2, and this feature is called memory low. So I have put the part of the kernel documentation for memory low on the right hand side on the top. And if you read the description, it's exactly that what we need. So the kernel will try to keep the memory of that C group in physical RAM. So it will protect against any form of memory pressure. And that's where I mentioned that WMP protects against both of the problems we've seen in the past. It's not only a growing page cache, it's also memory allocation from outside that C group. How do we set that? Systemd offers a directive for that. It's called memory low, written a little bit differently, but it's mapped to the memory.low feature of C groups. And systemd is the only way we can manage C groups in SLES15. Some of you may be aware of the lib cgroup1 package. It contains the cgconfig tools and cgrules engines. They are deprecated and have been removed in SLES15. So this is a SLES12 only thing. So in 15 you have to use systemd, and luckily it has a parameter for that. But there's a catch. If we look at the main page of systemd resource control, I have put it on the right-hand side at the bottom. There I bolded the last sentence there. It says the setting is supported only if the unified control group hierarchy is used. What does it mean? Basically, it's another word for we need cgroup 2 only there. So this is required. And this is only something which the systemd version used in 15 really supports. So you can't do this on the systemd version on SLES12 as well. So it's clearly 15. That's for SAP Applications 15 feature. So a little bit more detail to explain what that means with unified hierarchies, cgroup 1, 2 only, hybrid, and all the terms which will pop up if you deal with cgroup. The default in SLES15 is still a so-called hybrid hierarchy. So this means that under the mount point, SysFS cgroup version 1 is mounted. And I have put on the right-hand side a little tree command there. So this is the content of SysFS cgroup. And the black one, that's cgroup 1. That's the default. And you see for each cgroup controller, its own directory, and below the directory there's the hierarchy where you can organize the processes. So we have something for log IO, we have here something for huge table, there's memory, there is CPU set, and a lot of others. So this is version 1, it's still the standard. But in SLES15 you also see an additional directory, it's called a unified, and below unified there is the cgroup version 2 mounted. So that's, currently only version 1 is used so actively, but 2 is already there though on the sideline. For WMP, we need to switch to cgroup 2 entirely. So we're doing that by adding a parameter to the root command line. So it's systemd unified cgroup hierarchy equals 1. And of course, it's a command line, so we have to reboot the system to do the switch. And after that, if we look again at SysFS cgroup, you will see that's the unified hierarchy there. That's what was in the unified directory in the top part. And it's called unified because in this structure in cgroup 2, you don't have separate controllers for the features anymore. All the controllers are unified into one hierarchy. And in cgroup 2, you build one hierarchy, one organizational structure of your processes, and then you can switch each feature IO memory via files in that thing. That should make it easier. Having the unified hierarchy has implications because we don't see cgroup 1 anymore. The controllers are still available, except memory, of course, because we need memory for cgroup 2 for our feature, but all the others controllers still available. But if you have some solutions or some software which still uses cgroup 1, those tools might not work anymore. Because the feature isn't there, but if you see, we have changed the mount structure, and the tools expect SysFS cgroup look like the way it is above on the top. So it might be possible, hopefully, that these tools need just configuration. If it's going worse, then you need a new version to support different mount points for that. So the talk could be over here because we have everything we need. We have the kernel feature to protect it, and we know how to set it up, so we're done. That's a catch there. The tricky part is we have to get and to keep SAP processes in such a C group. So why is this a problem, or more precise, which problems would we expect or can we expect here? A little excursion to the SAP Stort Service, and I think most of you are familiar with SAP, know the picture on the top right corner. That's a very famous one. It describes the very complex SAP Start framework. And this is not a simple daemon, it's really a complex framework which is there for a long time, and it manages the starting, stopping, and all the operations with SAP instances. In the heart of it, we have the instance manager, SAP Stort SRV. That's the name of the process. It's each one for an instance, and each SAP Stort SRV has a child process called SAP Start, which is manages all the work process. So really, the instant itself. It's a central communication point. You know that for starting and stopping. If you want to do anything with an instance, you reach with the service manager via subcontrol, for instance, or using GUIs or web tools. And this entire manager is started via SAP init. So it's still a System 5 script, but anyway. So if this comes up, you would expect it, like any other service, that it is running as a root as a system D service. So, but that's not really the case. If you look at the right side at the bottom, I have tried to draw the C groups, the default C group structure there, and usually you have below several. In the first level, you have several C groups. I skipped the some of them, but the most important part are the system slice. And the system slice, normally you have all the system services there, the SSHD, Apache, cron, whatever you have should be there. And there's also that sub init service. So if you look at it, into that C group, sub host agent is there. And you have user slices for all the different user logins. So if you log into a system, enter your password, working with a shell, you normally have a specific slice below user slice. That's how it works. And this is important because, you know, sub-instances run normally as a dedicated user, as a SID ADM. And what SAP Stort SRV does, if it starts an instance, it opens a PAM session for a user, and then all the processes there are in user slices. So we have the sub instance anywhere on the right-hand side down, anywhere in user slices. I say anywhere because I cannot really say which user it is, because this is our first big problem. We don't know that because If you started via sub init, it will be the slice of the SID ADM. But if you started via SID ADM, so you log in and stopping and starting the instance, then it will be the user slice of the login user. And this is not usually the same. So it must not be SID ADM. You can imagine there are in many companies, there are rules that you have to log in as your user first for audit reasons, and then you have to switch to the SID ADM to do your work. So we don't know, or we can't be sure where the instance will end up. Second problem, SIG RDM do their work as that user. So all processes are in that slice. Every script you start, and that can include the complete graphical user interfaces. There are customers who are starting an X server with all the stuff and all the programs to managing a subsystem, and those would also too in that C group together with the instance. And you clearly don't want to protect the SAP instance, but you necessarily want to protect the GUI from being swapped out. And the third, more difficult problem is the way how memory low works. You have to set memory low on all the parent C groups. And this is a big problem because the user slice is below the user slice for a specific user is in a hierarchy in a user slice session. And we had where all user slices reside. And so we had set a memory low for that too. So we could protect all user logins for being swapped out just because we want to protect SAP instances. So anyway, it's very complicated and we run during the investigation on many such of those problems, but we came up with one basic rule, or what we need is the sub instances have to be isolated into a separate dedicated C group below root. So we need a separated C group, and we have to put only the SAP instances there. That's the idea. And the big question is, how can we do that? First part was covered. We have system D handling the subslice for it, setting the parameters, building up. Second part is we need to tell the service manager somehow, please put the instance there. And there is a way. If you look on at a profile of such an instance, I have put one or part of it on the right-hand side. Such instance profiles support the execution of programs. You have their little execute lines with numbers below, behind them, and normally there are things like cleaning up, copying binaries, preparing anything. So, and that's the part where we hook in. And the good thing about doing it on that, doing that there, is that we are inside the SAP framework. So every tool, GUI, program out there whatsoever, which is interacting with instances, have to use the proper official way, talking with subs.sre, with a service manager, to do anything with an instance. And because this solution is below that, it should work out of the box with everything was out there. So what do we do exactly? So this is also a part of setting up WMP. We have to add an execute statement where we call a program that we ship. This is a very tiny, very simple program which does nothing much. If it is called by a substart process, it will go back all the parent processes. If it sees a substart process, so the one that called it, it will move that substart process into the dedicated C group. And if all the execute lines are done, the substart program, which has been already moved there where we want to have it, will start the instance, and the instance is in the subslice and only the instance. So that's the idea. And if you use the system cgls command, you should in the end see something like on the right side on the bottom, there is a subslice. That's the thing that system D is setting up. And for each instance, you have a scope, and there is web start with all the instance processes and only the instance. So this was very technical and very fast. I just have 30 minutes and 10 left, as I see. Roughly, what do can we protect with workload memory protection? Sub-instances is the answer. So SAP HANA, NetWeaver, S4HANA, everything like that is covered. The sub-host agent is not, because the profile of the agent does not support execution. So it's out, but it's not that important. It's not really workload what the SAP host agent handles. And of course, all the other software which is not in SAP instance. So sub router is an example, but also any other tools like databases, so any DBs. But this is usually not a big problem, because databases have itself protection against swapping. Topic I left out for now is, I said there is memory low, but it's not a switch. You have to put a value in there. So you have to tell the kernel that amount of memory, please keep in physical RAM. And the question is, which value should I put there? So for an SAP HANA, that's very easy, because it's the global allocation limit, because there it's already known how much memory SAP HANA wants to consume, and that's usually the amount of memory you want to keep in physical memory. For application server, it's a little bit difficult, because the amount of memory that's consumed can vary, and also it is accepted for many customers that it really goes over the top, and swapping is accepted. So here you really have to know your workload and to find out where the sweet spots. That's the amount of memory. It's absolutely necessary that during that time we don't want to have swapping, but if it goes on top of them, maybe twice a year or once a month for special reports, then it is okay. Then I can accept swapping. So, and to aid you in this, there is we shipping with the package also a little script and a timer unit, where we collect information about the memory consumption over time. So we can see when the SAP application consumed that much memory. And in the documentation, I will have the link at the end of my talk. There's also a link to a little script in GitHub, which extract the information from the log and can present a little table that's easier, or you can create CSV exports, to have Excel, for instance, to create graphs, if that's easier for you. What happens if I set memory low to low or too high? So low, it's obvious. That part which is not protected will be swapped out if it comes to a memory pressure situation. So that's what expected. If you set it much higher than the memory consumption of the SAP processes, it's not that a big problem, because, and this is important to know, it is not a reservation. So we don't tell the kernel this amount of memory is exclusively reserved for SAP applications. That is not the case. See it more as a guarantee. So this amount of memory is kept in physical memory when SAP processes use it. Hearing that could come to the idea, hey, to be really on the safe side, let's set memory low very high, or ideally to exactly to the amount of physical memory I have, so I have always protection. This is not a good idea. In normal load situations, I think you don't see any issue there. But keep in mind, if your sub instance is consuming more and more memory and wants to eating everything which is there, so the entire amount of physical memory, then the kernel has to swap out other processes. That means non-SAP processes. And the SAP system is not alone there. You still have the kernel with all the necessary structures for handling the system. And you also have other system daemons like SSH or the log-syslog daemon. And they would suffer there. So if you do such a thing, setting memory low very clear or very near to the physical memory, you could put the system in an extreme stress situation, and that's exactly not that what you want. So please use a sensible value for memory low. Never use it nearly or even equal of the physical memory you have in the system. That could cause issues. So I'm almost at the end of my talk. Let's summarize what do you need if you want to use WMP. You need the package, which is in the repositories for SAP Applications 15. At the moment, SP2, SP1 will come very soon. Some manual configuration has to be done. There's the switch to C group version 2, that's a boot parameter, and obviously a reboot of the system. You have to determine the correct value of memory low and set it with a sysctl command. And you have to modify the SAP instance profile to call the capture program. So that's it. Just a few steps. Besides the memory protection, there are also additional benefits of WMP. One is you won't see any premature killing of SAP processes and shutdown anymore. I think most of you might have experienced that with SAP HANA, and SAP recommends that before you shut down the system, you should stop HANA processes. But I know that customers don't do that. They rely on the system to terminate services before the system goes down. And the catch here is that, as I mentioned in this talk, that normally SAP processes are in user slices, and user slices have a fixed timeout for, I believe, if I'm not mistaken, 100 or 290 seconds. You can't change that. And an SAP HANA system normally takes much longer to shut down. And if the time's up, then system D will brutally kill the HANA processes to shut down the system. And with WMP, we have no user slices anymore. It's a dedicated slice, so no premature killing. The system will cleanly shut down the HANA and then shut down the system. The second one is obsolete now. We had set it the task limits to infinity. This should address the problem many customers had with the system D user tasks max limit. But this is not a thing anymore for /15 because the latest system D update packages contain a fix where we set this to infinity, though not needed anymore. And also, what we are looking into at the moment is with having having SAP processes into a C group 2 C group. We could use all the other features C group V2 offers use there. So we have to see which opportunities we can have there. So that's finally it. The official documentation with some details and all the steps how to set up it can you find in the /SAP administration guide, at the moment only for /SAP Applications 15 SP2. Who is interested in the nasty details of memory low and in C group 2, I would recommend a talk from Michal Kutny from SUSE. It's a colleague of mine who helped me with WMP, especially the system D and the C group parts. And he gave a talk this year at the SUSE Labs conference about memory reclaim protection. So all the experiences he made with memory load during the development of this feature, and this is very interesting. And it, also you see, especially if you try to stack memory low in C groups with memory low, how complicated it can be. So If you're technically interested in it, I would really recommend to watch that. And also we have a technology showcase, and I have a little demo session there where I will show how this workload memory protection works, so you can see it in action. If you have further questions regarding WMP or ideas, don't hesitate to send me a mail. I have put my mail address there on the last slide, and time's up. So I thank you for attending. Have a nice day.